Okay, this question is a decision analysis question. It involves a sequential decision-making process when there are uncertainties, and then states of the nature can influence the outcome of the game, outcome of basically our decisions. Um, so let's just go ahead and go over the questions. There's actually a contract and awarded by the federal government, and the company actually has decided to bid $112 million. Actually, all of these numbers are in $1 million. So every number that we see here is going to be in $1 million. So for simplicity, we just put that aside. So there's 60% chance that the company win the contract, win the bid, and then if the company wins the contract, there are three methods that the company can decide and can choose for getting the oil out of the shale. These are the three ways: developing new process, using current process, or subcontracting, giving it to somebody else, outsourcing it. So, and then depending on the decision, depending on the method that the company chooses to use, there may be different outcomes with different probabilities. So if the company develops new processes, there is 30% chance of making a great success. And if that happens, there are going to be $600 million cash flow, or it uses the word profit, but that is excluding the money that has been spent, right? So that actually exclude the initial investment or initial cost, or the money that the company has to pay of $112 million. There is 60% chance of moderate success, 10% chance of failure with respective profit. If the company uses the present process, 50% chance of success, 30% chance of moderate success, 20% chance of failure. And if the company subcontract the project, 100% chance that they make a moderate profit with $250 million in profit. Moderate success and $250 million profit. There is a cost of $2 million. So if the company actually bids but loses, this money is going to be spent. I mean, this is going to be the loss of the company. If the company decide not to participate in the bidding process, they can actually go with an alternative venture and get a guaranteed profit, risk-free profit of $30 million. So just to save a little bit of time here again, I created the decision tree. So here's what's happening. So first, there's a decision regarding the bidding or not, if the company wants to bid or not. So there are two decisions to be made, either of these two. If the company doesn't bid, so does not bother to bid at all, there's going to be a guaranteed $30 million for sure. But if the company bids, the states of the nature is going to be winning or losing in the auction, in the bidding process. So if the company wins, which actually has a probability of 60%, the company is going to is going to spend $112 million, right? And then the profits, the revenues are going to come later, depending on the method that the company uses and depending on the success of the project. But if the company loses, so there's no revenue, but the company actually loses $2 million. So I just update that. Or I could have actually 0 and -2. That was actually, correct? So no revenue, but you have to spend $2 million in order to just participate and lose the auction. Okay. So, but again, 112, that's the bid. That's the amount of money that needs to be spent. So this is like um, a outflow, right? Or negative cash flow. And then there's going to be a second stage of decision making, and then after that, there's again another another set of states of the nature, and that would be regarding the outcome of project. And then there are different probabilities, and as you can see under each branch for each decision, the chance of these events is going to be, the total is 1, right? 1, 1, 1. And then we have finally the outcomes. Okay, so this is the decision tree. Whenever it comes to decision making, the branches that we have here, the decision maker can pick either of these, right? So we need to find the expected return under each one of these branches, and then pick the one that gives us the maximum. So in this case, I mean, if we end up coming to this part, if we win and we come to this branch, to these 3 branches that are actually going to be the decisions, then we definitely want to go with the maximum. All right. So, and then here, these 112, these are certain. That's why I put them here. I can also, if I want to deduct it from, or if I want to include it in the payoffs here and have a net payoff, then I can actually add it to all. I mean, minus, or I basically deduct 112 from each one of these values and update those. Okay, that's again another possibility, and I can remove it here. Same as this one. If 0 revenue, 0 profit, if I lose, but then there's an initial cost of $2 million just to participate in the auction. All right, so let's go ahead and calculate the expected return. So for here, the expected result, the expected income is going to be 30% chance. By 30% chance, the result is going to be $600 million. 60% chance, $300, 10% chance, minus $100 million. So if I get the weighted average of these, and basically weights are going to be probabilities, that will give us the expected result, expected profit from this. So that would be some product of these 3 probabilities and the results, or I can just do 0.3 times 600 plus 0.6 times 300 plus 0.1 times minus 100. That will give us the expected return here. And I'm not putting the formulas, but you see it right here. Expected values of probabilities and their result. That will give us the expected result of this decision. I have to repeat the same thing for the other 2 decisions, and then we want to pick the best decision. So we need to find out which one gives us the best outcome. So decision 2 is a little less in terms of the rewards that we get, and then subcontracting 100% to 50. That's it, 250. It's going to be the expected return from that. Okay, and then here the winning here. Okay, so for this, as you can see here, each branch is a decision. So now the decision maker can pick, and between these 3 decisions, these 3 options, these 3 decisions, definitely we want to go with the one that gives us maximum expected return, and that would be this one. All right, so between these 3, definitely you want to go with this one, and it's going to be this. So now here, it's going to be, I mean, I can just write maximum of these three decisions, which obviously is developing new process. We already highlighted this one. Plus the amount of money that 100% sure you have to either you will gain or you have to spend. In this case, it's a negative amount that you have to spend. So this is now going to be our cash flow if we win. Now, if we lose 0 plus, and I'm not going to update this, it's already here. So $2 million actually has to be paid for participating in the auction and for preparing the auction. And if we do that, and if we lose, there's nothing that we gain except that we actually lose $2 million. So the net cash flow for losing, or the net payoff, is going to be minus $2 million. But then the chance of this one is 0.4. The chance of this one, this is the expected return if we win, is 238. Now, the expected chance of, as you can see here, these are events, states of the nature. So when states of the nature, you have to find the expected value. So 0.6 times 238 plus 0.4 times minus 2. That would be the expected return from bidding in the auction. So 142 is going to be the expected return if you do this, if you bid. So if you bid and if you win, you will make this much. You will make, on expected sense, you will make $350 million. And if you lose, you're going to lose $2 million. But the expected, overall expected return is going to be $142 million. All right, let me highlight that. And these two, either of these two will be chosen here. So this is, I mean, I probably shouldn't highlight this because we don't, let's figure out this one too. If you don't bid, because that's the second decision. If you don't bid, you're going to make you're going to make $30 million, no question asked, right? So you get this one, $30 million. So obviously between 142 and 30 million dollar, right? So these are both in million dollar. You would definitely, if you're caring about the expected return, expected values, you would definitely want to pick this one, bidding. And then regardless of bidding, and if you lose, you lose. If you win, then the next decision would be this, developing new process. And overall, with all these possibilities, all these probabilities, and all the cases that may happen, the expected return is going to be 142. Okay. Determine whether the company should make a bid. Yes, if the company make a bid, there's going to be an expected return of expected net payoff of $142 million. And then this rest actually depend. And if company gets to the second decision making point, the second stage of the game, then the company should go with this one. So it's also important to state that at each decision making point, at each stage of decision making process, what would be the best bet? What would be the best alternative for decision making? Make a bid, participate in the auction, make a bid. If you win, go with this one. And it'll give you, overall, it's going to give you $142 million in an expected sense.